the Maintainable Software Podcast, where we speak with seasoned practitioners who have helped organizations work past the problems often associated with technical debt and legacy code. I'm your host, Robby Russell. On this episode, we are joined by Victor Rentea, who is an independent technical trainer and a lead architect at IBM based in Romania. Victor Rentea, it's a pleasure having you on Maintainable.
It's a pleasure to be here. Thank you for inviting me.
So, what do you believe are common traits of a healthy and maintainable software code base?
Well, when you say maintainable, automatically someone should be able to first understand the code in order to change it. Most important is the code should be readable, should be a pleasure, should be very, very, very easy to comprehend. On the other hand, it also requires that changing code doesn't cause you moments of panic. Changing the code should be safe for you, meaning that there should be a suite of tests covering the most intricate part of that code that you are refactoring, that you are looking into in the end. So basically, very often I find that maintainable code is a code which is friendly to you, meaning that you can get your hands in there in a safe way. So these two are the essence of maintainable code, readable and safe to work with.
You touch on being kind of a pleasure or being friendly for developers, so that kind of touches on the developer's experience. How do you find teams typically talk about their code bases when it comes to like the problems, and maybe their technical debt is like one phrase that might be used, but when they're talking about their source code of their applications, do you find that they often talk about it in that it is a friendly way, or is there more in your scenarios you're typically working with them where things are not so friendly?
Good question indeed. As I move from company to company with my training activity, I find various teams that I have to admit the vast majority of them working on existing code, on the so-called legacy code. Most of them, when I talk to them about refactoring, about reshaping the code, about how to work with it, they are mostly reluctant. I mean, they do agree with the ideas that I'm discussing with them. They do agree that the code that we work together ends up being cleaner. But in the end, I feel in them this fear, this anxiety of touching their code. I mean, in the end, they are largely afraid, technically.
And so when you have, you're in those environments where developers are, have this existing anxiety, you mentioned like legacy code and such in there as well. Do you find that there's something that developers often get wrong when they're talking about the problems with their code base?
What I feel many teams are missing, many teams don't realize that working with legacy and actually building tests and refactoring stuff, it's one of the most difficult challenges out there. It's way more difficult to work with existing code and write new buggy code yourself. No one clearly highlights that you have to sharpen your skill. You have to sharpen your reflexes before you jump on the beast on the legacy code. Meaning that there is a set of core skills that you owe to acquire. And nobody actually often talks about these kind of skills, about the analytical skills, how to read code. This is actually something which is missing from the computer science curriculum throughout the entire world. Hours of reading code. Exercises of comprehending code, reading the others' code, because this is what you will end up doing at work in the end, 80% of the time, reading others' code. No one actually puts an emphasis on sharpening skills. So basically, most teams are somehow surprised at how hard it is. Most teams don't expect it to be that hard, and somehow they feel that there's something wrong with them in the end. But it's natural. This is one of the toughest challenges, right? To understand others' code and to change and to dare to touch it and to change it. So, from one perspective, I could argue that people must admit that the difficulty of this task and must take proactive actions to grow their skills towards this direction. This is one way that I always suggest teams to go about. I mean, do work together on some safe examples, do some coding katas, do some exercises to get comfortable with refactoring code. I was just working today with the team. Basically, I insisted so much on them mastering the IDE, whether it's Eclipse or IntelliJ or maybe even NetBeans. You ought to know those refactoring or those automatic refactoring mechanisms that you can use. And the common metaphor that I give them for that how you feel when you just started driving your car by yourself after you've taken the driver's license. First day without the instructor next to you, you panic if your girlfriend opens the radio, you panic, you just have a heart attack. After 10 years, you don't even think what you are doing when you're driving, right? You're in the same time, you're doing three things at the same time. Why? Because of the reflexes that you acquired. The same happens when you drive through legacy code. If you don't know how to extract a method, if you don't know how to sense a new responsibility, if you don't know how to inline to something, then you're lost. You're just day one. And it's very, very hard for you to work with legacy code without these reflexes.
You touched on that there's a gap in, say, the education curriculum for most computer science programs. And that's always been something I think that's been interesting as someone that employs developers. And most of the project software that we ever work on tends to be existing software. Nobody comes out of school and gets to work at, rarely probably, gets to work at a company where they get to be like, all right, I'm building a brand new app from scratch. And it's like you're usually coming into an environment that has an existing team and years of code and different approaches and things that good guesses on how to approach certain things and things you wish you would have done differently. And it's kind of like such a huge shift from what you'd learned to how to build things from scratch to like, oh no, how do I make sense of this existing world? It makes me think about other things that people learn about in school, like writing. I think probably an important part of like writing is probably knowing how to read. And I think there's probably some correlation there, but I always wonder why that's not more of an emphasis on just, you think you're right, on understanding, comprehending, changing, improving existing code and knowing that there's pathways to do that.
Well, related to that, software engineering, in the broader sense, programming, it's very difficult to acquire. Therefore, our entire preparation to become a software engineer, during faculty, during maybe some bootcamp that you followed if you come from another branch, during all this preparation, you always work alone in your cave, alone at night, trying to break this thing, this algorithm, this task. And suddenly after you've graduated, you come to work and you have colleagues, and you suddenly that other atrophic hemisphere in your brain has to work. Suddenly you have colleagues, you have to talk to people, you have to accept others' opinions. So it's very difficult for someone with the preparation, with trained in computer science, to work in a team. In faculty, very, very few assignments, at least in my curriculum, were including teamwork. And usually when there was teamwork, only one of the guys did all the job, all the tasks, and the others are just advising and not really working together. So until you really get employed, you never work together with someone.
Yeah, that's very true. We hire some people that come through a boot camp, and I've seen them make some progress there where they're spending like almost 50% of their time pairing with people. But you still get a sense that like there's usually like in those scenarios, there's one person that's kind of driving and the other person's kind of like trying to keep up a little bit. And then you can kind of tell who benefited from that a little bit more than the other. But I think that's good that I'm seeing some of that there because, one of the things that's very important, people start and if they've kind of had that lone wolf programmer mentality for a long time, then it's very challenging to all of a sudden go, yeah, I'm now a part of a team. And how does that work? Let's talk a little bit about your training background. So out of curiosity, how did you find your way into becoming a technical trainer?
I wanted to know the details of what I was working on continuously. I initially started with certifications, but when there were no certifications for a certain field, like for example, REST services, again, I felt that the best way to learn myself from a selfish point of view was to teach the others. So I started with mini workshops of 1 hour or 2 hours during work time, on which any other colleague of mine could join from whatever floor, just to learn myself, right? And after doing this for several years internally in my company, I finally decided to step forward and to go to other companies. And now this is basically taking almost half, if not more of my time. But again, this is all out of a pleasure to learn in the end. Because there is no other way of learning something better than teaching the other. There were I'm not recalling the exact figures, but you remember 15% of what you read. You remember, it was a scale. And you remember most when you teach the other. That I can testify. That's it.
Yeah, that's great. Yeah, I was actually just reading a book recently, unrelated to software development. It's called like The Business of Expertise, and it puts so much emphasis on like you need to be making lists of things you want to learn about and then teach people that. And that being like this list you should be evolving. I thought that was interesting to kind of just think about from my type of role in my organization. I found that when our team members here in my own company will provide workshops, sometimes it's on things that they've just recently learned about. And it's always good to be like, hey, you just learned that thing. Could you teach other people about it? It's not like, go do research on that. The end result shouldn't be having just done research. It should always be and presented to the team. Because if you don't do that, have that kind of follow through, then how does the rest of the team benefit from that? Like don't go on an exploration mission by yourself and not share some photos or something afterwards. So I think that's good. And it's interesting to hear how that kind of became like a natural path for you to get into doing these types of workshops and things that you're now doing. I was looking through like the types of things that you're training on, and I know you touch on a lot of things related to like Java and specific programming languages thing, but what aspects of software development are you often training development teams on?
Historically, let's say, I've started with frameworks and language. I mean, teaching somebody else Java 8 or Spring or Hibernate is not much of a challenge in the end. It's a framework. It's a tool, right? What I found much more interesting is to teach them disciplines, is to teach them ways of thinking, meaning test-driven development, design patterns, clean code. These three are now currently my main focus area. And I've taught design patterns in Scala, in Java, in PHP, in C#. The principles, the ideas are mostly the same. So this is something way more deep. This is something related to how you tackle a problem. One interesting topic, how to juggle with all the three paradigms at once, functional, procedural, or object-oriented, when to use one, when to use another. So these kind of questions are way more deep, trigger way more interesting discussions, and this is my main interest area now. And the fun fact is that after each training, I adjust almost a dozen of slides after each training, because every time I learn something new, every time I see a different perspective, a different correlation, a different idea. So it's a topic very, very deep and very, very interesting for me.
I appreciate you touching on just how as you're going through this process and you're learning and discovering a lot from having talked with these different teams and stuff. And I think sometimes for those that are listening that think that maybe one day they like, well, I don't know that I could ever become someone that could train other people on these things. I think it's helpful to know that it's part of the learning process. You might have a lot of experience in there. And I don't know whether you would call yourself an expert or not on these topics, but I think there's an aspect of knowing that the people that are actually training and helping people are also going through their own journey of learning and evolving their understanding of these topics as well.
Calling yourself an expert sometimes is dangerous. Why? Because it means that you acknowledge that you've reached the end of the line. No, I'm not an expert. I'm an apprentice, right? And there is this amazing book, Apprenticeship Patterns, that I recommend everyone who wants to know the path to walk. I mean, it's about attitude, about how to maintain a continuous learner attitude, because you never know everything, that's for sure. So continuously learn, and don't aim to become a trainer, aim to learn more yourself. If by doing that, you teach the other even better. So always think not only of yourself. I normally say to my training groups, if you have more than 10 years of experience, you have no excuse not to try to teach the other. That's your moral duty in this branch, because so many new things appear every day. So it's your duty as a senior to teach the others. I truly believe that.
Do you believe that in-person training is more effective for a team than, say, purchasing them all the same book and or sharing links to articles amongst your Slack group?
Well,
you might be a little biased on that, I admit.
Let's put it this way. Working on the same projects for several years entrenches you in a set of practices, of a way of thinking. Pulling you out of there is sometimes a tremendous effort. Most people can't simply escape the mindset they've grown into for several years unless they are dragged out of it. So basically, most of my time in training is not presenting new things to participants, but motivating them to dare to exit the mindset that they've settled into. Meaning here, daring to touch the code, daring to do design, daring to create classes. Yes, to create classes. I normally say in a fun style, what do you do when you come back from the bathroom? You wash your hands, of course. And what do you do next? You create a class. A tiny class, just to prove yourself that you can create classes, that you are not afraid to do it. Don't be afraid to design. Don't be afraid to create new things. I know that you've grown into into being afraid of touching the code, but your continuous goal would be to break up classes which grew unexpectedly big. This is the main problem in software development. Things which originally are so small grow wildly, very, because we're just adding more ifs, more fors, more ifs to the same code. So your continuous fight should be to break things up, to break classes and to separate by responsibilities. This is something which takes a lot of energy and a lot of courage, right? That's what I'm fighting with actually in my trainings, really.
It's an internal struggle for people and not just a technical challenge that's in front of them.
Yes, it's a psychological challenge indeed.
I think as developers, there's this challenge of being, maybe we're not using the latest versions of things or things getting outdated, what have you, or blaming other aspects or the code that someone else wrote. Are you actually, when you're working with these teams, do you find that a lot of the people that are actually working on the code were around for quite a while in that project? Or do you find that when you see that there's a difference between developers that recently joined a team and there's all these underlying issues and they're like, it's like a scapegoat of talking about the previous developers by talking about technical debt?
That's a great question, because the vast majority of the developers that are in the room are the ones who wrote the mess a while ago. Basically, any code you wrote more than 3 months ago, it's legacy, right? You become really a senior when you realize that your code that you are writing now is tomorrow's legacy code, right? So always think of your code as already being legacy code. And I want to touch a bit on a point you've mentioned before. People coming out of faculty and joining in companies and them wanting to do greenfields, but always being put to the work on legacy code. And I want to emphasize one thing. You as a software developer have two kinds of skill set. One of them is the ability to juggle with frameworks and to design and this is what you can grow easily in greenfield, right? Many people ignore that that's not the only skill set, not the only ability. Sometimes, more importantly, is to be able to understand, to analyze the code and to be very critical about the code. This is the analytical skills that you can only work out in legacy code. So legacy code trains this side of your skill set, the ability to really understand the code in depth. So don't run away from legacy. This is where your skills will be forged in battle, let's say, right?
So maybe taking a quick step away from, your training expertise as a software engineer, maybe you're in providing some consultation on projects. When you come across some areas of code that you believe would really benefit from refactoring, but maybe that doesn't currently align with the client's priority list of what's in their backlog of things that they're maybe looking to you as an external developer or they're amongst their own team to prioritize it. How do you help that team understand the importance and get buy-in on prioritizing that refactoring work?
The true question is, what code should I refactor first, right? Which goes hand in hand with what code should I unit test first? Or what existing code should I cover with tests first? And the criteria here is very, very simple. The code that annoys you most. The code that you fear most, that annoys you most. Not the code that you never seen for years. The code that you've been last week, last 2 weeks, last month, continuously over the past 6 months. That code that kept annoying you, that's the best code to start refactoring. Like Martin Fowler says in his wonderful book, Refactoring 2nd edition. He says, I will tolerate a mess when I first see it. But if I see it again and again and again, I will just jump onto it and I will refactor it. So do tolerate a bit of mess. If you just walk through it once, okay, maybe you won't go there the second time. But if some code keeps bugging you, that's the code that you should refactor. And now, regarding putting this on a list, never, ever, ever, ever separate the task of refactoring from the task of getting your feature implemented. You should never put refactoring on any board, anything. Refactoring is a part of your duty as a professional. Again, quoting Martin Fowler, you've hired me because I'm a professional. Because I'm a professional, I refactor. This is how I work. This is not an option for you. Nor is testing. So you either like how I work or, trust me, I will find another employer with no issues if I have this attitude.
That's a good point there. And I've talked with some people in the past, previous guests who've talked about, you don't need to ask for permission to provide quality code. And like one of the ways that I guarantee my code is of quality is that I've written tests for it. It's not a like thing you need to ask permission for. And I think that's interesting to also think about how refactoring fits into that. I don't know what your typical process is like with your clients, but I know that some people might be met with we need to build out this new feature for this application. And maybe they have like kind of a rough estimate of how much time. So they have like a timeline for that. And then you start getting into it a little bit more to understand how this is actually going to get approached. And you realize, I'm going to have to do a bunch of refactoring to accomplish this, to make things smoother. Now I'm going to blow the budget or the schedule. What sort of advice would you give to people in that type of scenario? Because I think that's probably what people might fear the most, is being like, that would, if I only had more time, then I could do that. But
this can indeed become a great problem, a great stopper for, being rushed all the time and never having a word, never having the ability to stand up and say, okay, stop. I want to do a great job. I don't want to be rushing. I don't want to be patching around. I want to do a great job. Now, this takes first courage, then commitment. Not all of us are able to commit that, to promise that they will do a good job. It depends on the stage that you are in your life, on your work style, on many, many, many factors. So it takes courage, if not anything else. But then it's also very important. You want to do some refactoring, but the business keeps rushing you towards delivering features. So you have this decision to take. Now, there are several possibilities. One approach, an obvious approach, is to overestimate, right? Is to overestimate and use the extra time to do the refactoring that you've foreseen, or maybe that that ought to be done. Again, in this regard, I want to quote Ken Beck this time, who says you have to do a difficult change. The first thing you do, you make that change easy. In parentheses, this might be difficult. And then make the easy change. In my opinion, the best type of refactoring is the preparatory refactoring. The refactoring that you do before you put your new feature, right? Cleaning up the stuff and then adding those 3 new lines to solve the entire feature. That kind of preparatory refactoring you can foresee at times, and you can estimate it accordingly to include this refactoring. However, if suddenly your estimates will start growing, business will start wondering, why? What's happening? Are you trying to be idle, or what's wrong? And first of all, you must be honest at all times. If you lose the trust of business, you've lost the game. But then there is one more trick that you have, one more ace in your sleeve. You are the first who sees the application. Never forget that. You are the first human who sees what you're building. Use this in your advantage. What do I mean? You aren't allowed to leave any demo pass away without you proving business, or the one who own the money, right? Proving them that you want the good of the application. What I mean is that you should at any demo come up with several suggestions, improvements, simple things at times, maybe some silly round corners, maybe some keyboard shortcuts, maybe some, I don't know, look, wouldn't you want this little button to do this additionally for you? Suggestions. Don't do them for free, but give them suggestions. Prove the boss that you are a partner, not a worker. That's fundamental. You are a partner, not a factory worker. The moment business will accept that you want the good of the application, they will start trusting you more, and they will start trusting your estimate. This is one way that you can get the necessary time to do your job, right? But there is another issue now. Let's now suppose that you have to do a huge refactoring, that the application is a very deep mess. What do you do? Technically, by just asking 2 sprints of refactoring, no one will grant you a sprint of refactoring. If they do, that's something amazing. There should be in a newspaper, right? Well, what do you do then? You want to do a dramatic change in the application. You set the goal using some meetings with the developers, and every time you have the chance, you herd the code. You push the code towards that direction, slowly moving. You can do amazing things if all of you work together in one direction. Every time you go to some classes to apply certain changes continuously, and every time you go slowly in time, in weeks and months, you can do an amazing job if you work together as a team.
I think that in particular, the advice of being a good partner, not just being seen as a factory worker, I think that's really compelling. I think there's a lot, they should definitely think about that a little bit. I just imagine there's a lot of developers out there where they find themselves in a position of they're just getting past the next item in the backlog. They're picking those out of the backlog, however their process works. They're just delivering things and moving on to the next thing. It's kind of like this ongoing slog, and they're always up against like a timeline and not feeling like there's going to be time to actually go back and visit this stuff. Or maybe they've hinted at some of these issues or brought them up like, hey, we need to clean up or refactor this area of the code base. And we're like, well, not right now, because they're specifically asking to do like a bigger refactoring phase. And maybe that's not going to be an easy sell. But if they think about how can be part of their ongoing process and just be part of, I think, as we were touching on a little earlier about making that be part of your deliverable task, like what needs to get cleaned up. Other people have talked about, I can't remember who I'm quoting here, but something along the lines of, like always leave the place that you're, wherever you go into an area of code, make it better than when you found it, You can also, being an advocate for the product or the software that you're working on and like helping highlight the things that show that you're interested in more than just producing code shows that does go a long way. And I think it's probably good advice outside of just helping you get the time to be a good refactor, but being a good team member in the wider aspect of the organization. It's not just you learning to be a good team member amongst your development team, because you're all going to have that little bubble, but actually talking with like the other business stakeholders. And that's important too. We'll be back with my interview with Victor in just a moment. Hi, it's me, Robby. I want to thank you for listening to the Maintainable Software Podcast. I have a huge favor to ask, though. So I've recorded a little over 20 episodes so far, and as they've been published, I've had less than 5 people actually submit a review on Apple Podcasts, which isn't how I'm defining success, but it does impact their algorithms and how other people are potentially discovering this podcast. So if you actually think it's worth listening to and want other people to hear it, outside of maybe consider sharing it on social media, which I really appreciate it would mean the world to me if you'd provide an honest review on Apple Podcasts. And admittedly, if you have some critique, I would love some feedback through that. So please consider doing that. And with that, back to our interview with Victor Rentea. So maybe there's a developer listening right now, and they have good intentions and are thinking to themselves, this sounds great, but how can I convince my colleagues to make this a habit as well? What advice would you offer them?
First of all, grab a copy of Sandro Mancuso's book, The Software Craftsman, and read the chapter about convincing skeptics. That's a full chapter of convincing people who just are not really much into it. And there is a very nice classification of the types of skeptics you might face. Just to give some examples, there are some who will just follow the herd. There are others who got burned. There are others who are maybe lazy in a sense, or there are others who don't want to get down from their ivory tower. Who knows? For each of these categories, Sandro suggests several approaches, but the overall suggestion is the following. Whatever practice you want to adopt, to embrace, maybe it's TDD, maybe it's pair programming, maybe it's continuous refactoring, whatever practice you want to spread in your team, there are several points to consider. First, you must give an example, right? People should see this happening next to them, should see how fun it is. Because honestly speaking, refactoring is addictive. You should see how fun, and also pair programming, you should see how you should make it fun. You should make it at least appear fun, right? Then you should always offer to help them. You should be very, very gentle with them. So there are several suggestions. So I strongly advise you read that chapter. The point is always be there and show things to them continuously. Again, it's not an easy task, and sometimes you will get depressed. When you get depressed by fighting with the system, let's say, maybe not the colleague, maybe the entire ecosystem that runs the team, then you ought to have someone next to you to support you. On an emotional point of view, this is sometimes called the kindred spirit. Someone who will back you up. Maybe it's a junior, maybe it's someone less experienced, way less experienced than you. It doesn't matter. Someone just to share your vision, right? And you have to have someone with you. That's another key point. Otherwise, any human will get depressed sooner or later, right? But don't despair. Keep fighting.
Some really good advice there. I remember you mentioned how refactoring can become very addictive. And my own personal experience was, I remember when someone recommended reading Martin Fowler, I think first edition refactoring. I think I was probably introduced to that, I want to say 16 years ago, maybe. I think within like a day or two, I was just like so obsessed with like going in and cleaning and refactoring. And I was like, this is so fun. And that was never something I would have thought I would enjoy as much as I ended up doing that.
My trigger were the Clean Coders videos of Uncle Bob. Those completely shook my world and threw me out of the factory worker mindset. So I strongly advise you either the Mighty Fowler's book, indeed, extremely good book, or the Software Craftsman from Sandro Mancuso, or those videos. These are amazing resources to get you out of there.
I think this is a good point to start wrapping up, because I think people are going to go away and need to do some thinking about what they're going to do next. If there's one thing that they could probably fit into their schedule in the next, say, business day, maybe they had like an extra half hour, an hour, and they're thinking, there's so many things I should probably tackle. But maybe if you were to offer like one thing that you feel like is framework agnostic tasks that they can go and feel like they've made a step in the right direction, what would you advise them to do?
There are these famous coding katas, which you can work out many, many times. There is actually a book that I always recommend to my trainees, which is the Coding Dojo Handbook by Emily Beccia, I think it's pronounced. This is basically a catalog of programming katas. As you say, completely agnostic to language or framework. The three major types of katas, the refactoring kata, the TDD kata, and the legacy code kata. Simple examples to work your skills, to work your reflexes. There are katas that I've done more than 50 times, which is 50. More than 50 times, the same exercise over and over again, with different restrictions, without a mouse, in pair programming, without speaking, many, many restrictions, just to work out your skills. Some, however, was said to me, okay, but where do I get my ideas? Hand down the video, the screencasts, some coding screencasts from the big guys, like Uncle Bob, like Sandro Mancuso, like hand down screencasts done by those who call themselves software craftsmen. And because these are the ones, some of the most passionate developers. So see how they refactor code, get those ideas. First of all, start by just imitating them, right? And then just to see, just listen very carefully, watch very carefully what they are doing, and then try it yourself. Try it in a different way. Try to work some simple problem in as many possible ways you can solve it. Work out design and think about trade-offs and write, but not production problems. Simple exercises, solving them in a safe environment, comfortable, half an hour a day, maybe when you get after lunch, when you're doing siesta and your brain doesn't work anyway. Just try to continuously work in this direction.
You've recommended a lot of great books in this conversation, and I'm going to challenge you. What book would you say you most often recommend to software developers that's not about software development?
What do I recommend? It's not about software development. Interesting. Well, that book, 7 Practices of Highly Effective People. But there are a number of books out there which don't contain any line of code, but which are written by the brightest minds in IT. One that comes to my mind now is Extreme Programming Explained by Kent Beck. These books about attitude, not about professionalism. Or another book that I would recommend, Apprenticeship Patterns. Learn how to learn. Acquire this mindset of continuous learner. There are books about attitude, about how you can grow and how you should behave as a developer, but which are actually drawing their ideas from many other non-technical books.
Great. And so where can people learn more about you online?
Well, I have a website, victorrentea.ro, and I also have quite a bunch of YouTube recordings of various conferences. I have quite a large number of recordings, but I do have a playlist on YouTube with the best talks. I tend to do the same talk several times, but the one which is the best, it's part of that playlist of mine. You can find links to everything from my website.
Well, excellent. Well, it's been such a delight having you on Maintainable, Victor. Thank you so much for joining us.
Thank you for having me.
Maintainable.